Alright, we're going to talk about multiplication of integers now. And it's not too bad, but there is one thing that we need to get straight. And that is the following. And I'm sure you've learned this in your entire school career, that a negative times a negative is a positive. But I find most students were never taught why that must be the case. Why is a negative times a negative a positive? And it's not too bad of an idea. And it turns out that if we want those nice properties of numbers that we already have to hold, then this must be the case. This is the only thing a negative times a negative could be, is a positive. So I want to convince you of that now. All right, so here's the expression that I want to show first. That if we multiply by a number by -1, we get negative that number. And this is for any integer. So this is what we need to show. And the way we're going to do this, we're going to start with something we know. And the idea is we're going to see if we can get this expression a times -1 in there, because we're going to pretend like we don't know what this should be. And you have to think the first person to discover that a times -1 should be -a didn't know what this should be. So we're trying to get in that mentality. So when we see this a times -1, we're going to treat it like an unknown. Okay, so I'm going to start off with the following expression. In fact, let's call this a proof, maybe. So, let's consider the expression 1 plus -1, that equals 0. And how do we know that equals 0? That equals 0 because we know 1 and -1 are negatives of each other, opposite numbers. So we can say by definition of negative numbers. So that's why we know this is true. Okay. So what I'm going to do, because the idea is I'm going to want to get this a times -1 expression appearing somewhere. So I'm going to multiply both sides by a. So if I multiply both sides by a, what do I get on the left-hand side here? Well, I get a times 1 plus a times -1. So what I'm doing there, I'm using the distributive property to multiply the left-hand side by a. So that's because of the distributive property. Okay, and we also know that, well, what's 0 times a going to be? Well, 0 times anything is 0. So we know that this is going to equal 0. So the right-hand side equals 0. So we can say we know this holds by the distributive property and by multiplication by 0. And we're happy with those things. They're properties of numbers that we already know. Okay, let's simplify even more if we can. And we can. So what's a times 1? Well, anything times 1 is itself. So a times 1 is, of course, just a. So we get a plus this, a times -1, that equals 0. And that's the multiplying by 1 property. We know what happens when we multiply by 1. 1 does nothing. Okay, Now, I'm going to resist the urge to simplify this, because remember, we have to pretend like we don't know what this simplifies to. We have to solve for it. We're treating this like an unknown, this a times -1. Well, let's look at it like this. There's a couple ways to look at it, but maybe the easiest way is I have a plus some number equals 0. Well, by the definition of negatives, this must be negative a. Since it's the number, when I add a to it, I get 0. So I have that a times -1 must be negative a by the definition of negative numbers. So, let's go over what's happening here. And it's the following. If we want our mathematics to have negative numbers in it, if we want the distributive property to hold, if we want multiplication by 0 to hold the way we expect it, if we want multiplication by 1 to hold the way we expect it, if those things are important to us in mathematics, which I think most people would agree are, then it must be the case that a times -1 equals negative a, which is really cool. And I guess similarly, we could do it in the other direction as well, but I'll just leave that as an exercise for you guys. If I have -1 times a, I also get negative a. So there we go. So we have, when we multiply any number we like by -1, it gives us the negative of that number. And this is why, because it must be the case. Okay? Well, kind of as a, what do I want to say? As a direct consequence of this, -1 times -1 must be, well, if we say a is -1, then -1 times -1 is going to be -1. So -1 is, of course, +1. So -1 times -1 is +1. So, and that's just the way we show that, is we're just letting a be -1 above. So it's an example of this general result here, which is really cool, but it's a very useful example of this general result, because now we can do things like this. Another consequence of these things is that if we have negative a times negative b, that's just a times b. And why is that the case? Well, let's just prove that really quickly. Well, negative a I can write as a times -1, just from above, right? That's what we showed. A times -1 equals negative a. Well, we could show it in the other direction as well, so maybe I'll write negative b as -1 times b. Okay? And now, well, what do we have in the middle here? We have this -1 times -1, which we know is 1. So we have now a times 1 times b. And what multiplying by 1 does nothing, so this is the same thing as a times b. So now, if we have two negative numbers, we know we can just multiply, and the two negatives cancel out. So that's why this rule, negative times a negative is a positive, holds. So when you're in your teaching career, hopefully this will be good for you guys so that you know why this must be the case. And when a student asks why, you just don't have to say, well, it's just the rule. It's not a rule for no reason. It's a rule because it must be so. And here's why it must be so.